Hi, second graders. Today we are going to be talking about earth science, that is science involving the earth, and we're going to go into weather. Let's get started. So, what is weather? Weather is the daily state of the atmosphere or air in any given place. So, the atmosphere is the air above us till you get to space. So, for example, we have daily or weekly weather forecasts. So forecast would be something like this, where it talks about the different days of the week and what weather we're expecting and how to describe that weather. Okay, let's go on to the next slide here. So as we just saw, we use a lot of different conditions to measure weather. Let's cover those conditions here. So weather, what do we measure? So we use these to measure the weather. We use temperature, precipitation, sunrise or sunset, wind speed, and direction. So those are the four things that we most commonly use to describe weather. Let's talk about them a little bit more here. So temperature. Temperature is the measure of hotness or coldness. It is a measure in degrees of Fahrenheit or Celsius. So in the US, we use Fahrenheit to measure the temperature, but most other countries actually do use Celsius. But really right now, we're only going to worry about Fahrenheit. So this would indicate a hot day. This would indicate a colder day. Precipitation. Precipitation is the release of water from the sky. The water can be rain, snow, sleet, or hail. So as you can see, we got rain, snow, sleet, and hail. Weather, sunrise and sunset. So sunrise is when the sun starts rising in the horizon, and the sunset is when the sun starts to set in the horizon. So the sun rises in the east and sets in the west. So I just wanted to show you guys these pictures because I think they do a really good job of showing sunrise and sunset. This is the path of the sun during summer. This is your house. Let's pretend you're in your house. Your house faces west, which is a cardinal direction, right? So starts in the east, goes across the sky, sets in the west. Not directly in the west, but mostly in the west. And then this is the path of the sun in spring and fall. So it's a little lower than the one in the summer. We'll get to that a little bit more in just a moment. All right, so wind speed and direction. Wind speed is the speed air moves because of weather. Wind direction is the direction the air is moving, north, south, east, west. So when you guys look at a forecast, I just Googled this one, but you can see it shows the miles per hour that the wind is moving and the direction. So it has the speed and the direction. This is like this is a map of our state that shows the severity of winds and the direction. So if it's green, they'll usually have something like this, like a, what is it called? A guide. It'll say 1 to 10 miles per hour winds, that's the green ones, 11 to 15 mile per hour winds, yellow, 16 to 20 mile per hour winds is the orange, over 20 miles per hour winds is red, and I only see one of those on these maps. So this is a map that they'll show usually of the entire state, and this is one that you'll find on just like a weather forecast for, I just looked at Minneapolis. But how do we measure the weather? That is a great question. So we use a few different tools to measure the weather. They are an anemometer, a rain gauge, a thermometer, and a weather vane. So an anemometer is a tool that is used to measure the speed of wind. A rain gauge is a tool that collects and measures the amount of rain that falls. A thermometer is a tool that is used to measure the temperature of the air. And a weather vane is used to measure the direction of the wind. Okay, let's take a look at these. So this is an anemometer. This also has a different tool on it, but we're just going to focus on these little cups. Okay, these little cups, they spin, and they have a and you can count the rotations within a minute to figure out how fast it is going per minute, how many rotations. And then there are math calculations you can do. We're not going to cover those, but there are ways to figure out, based off of these little cups, how fast they're spinning to figure out how fast the wind is going. This is a rain gauge. This is like an old school, just normal one. It catches, it has measurement markings. So this will show how many measurements of rain they got. This is an electronic one. This would be something used by a farmer or a meteorologist, someone who maybe measures the rainfall pretty often. And it's attached to like a digital display. So this will probably display like the information of how much rain has fallen within a certain amount of time. And this is a thermometer. So a thermometer has a special substance in it that as it heats up, it expands. And as it expands, it shows us what temperature there is. So on this side is degrees of Fahrenheit. You can see it, it's the little F. So that's how we know that it's degrees Fahrenheit. There is Celsius on here. So you can actually see on one of these what the equivalent is. So this is saying 75 degrees Fahrenheit, and this is just over 20 degrees Celsius. So that's kind of a comparison for you to look at if you want to. Over here we have a digital thermometer. This one is one that you would put in your house, and it displays a lot of information: outdoor temperature, low, high, indoor. I'm assuming it probably connects to the internet and maybe has like an infrared laser to measure the indoor temperature or something like that. And this is a weather vane. A weather vane will show us the direction of the wind. Okay, so look at this. This is like an old school one. You probably have seen these before on barns, old houses, in TV shows, stuff like that. It simply just points in the direction the wind is blowing. So this chicken and this arrow will face that way. Now this is like a digital weather vane. This one has the weather vane part on top, and it has an anemometer on the bottom, which again we talked about measures wind speed. So this one's digital. I'm assuming you can see some sort of box over here. I'm guessing this is where the information is displayed. This one would display both the wind direction and the wind speed because of the weather vane and the anemometer. Meteorologists are scientists who study weather to help us predict and understand future weather. So they are the ones who use these tools. If you use these tools, you would also be a meteorologist because you would be a scientist who's studying weather. Meteorologists are also the people, because they can understand the future weather based on current weather, they are the ones who come up with forecasts. So if you ever watch a newscast and you see a meteorologist talking about the weather, they study the weather, so they actually know a lot about it. So the most common types of weather, and these are symbols you'll usually see if you look up the weather online. Snow, you'll see a cloud with little snowflakes. Windy, see kind of like some wind marks, like it looks like the wind is blowing and the cloud has wind blowing. Foggy, a rainbow. Sunny, rainy is right there. Thunder, and cloudy. I'm not going to go over these because these are common, we all know these, but they're still good to know. So let's talk a little bit about extreme weather. The types of extreme weather. Extreme weather is any dangerous act of nature fueled by changes in the atmosphere that puts people, animals, or buildings at risk. So the types of extreme weather we're going to cover in a video next is tornadoes, blizzards, hurricanes, floods, and droughts. If you don't know what those are, we're about to find out. Let's watch this video.
Hi guys, welcome back. Today we're going to talk about... Sorry about that. Today we're going to talk about... Are you finished, Thunder? Thank you. Thunder's pretty excited because today's episode is all about it. Well, to be more specific, today's episode is all about severe weather. But before things get all snowy, windy, and rainy in here, let's bundle up and ask ourselves the big question. What exactly is severe weather, and how is it different from regular weather? We know that weather is a condition of the air or atmosphere on our planet. Severe weather is the same thing, only more extreme. Extreme! But what does that mean? How do you know when weather is severe or extreme and when it isn't? Well, severe weather is any dangerous act of nature that puts people, animals, or buildings at risk. Some light rain probably wouldn't count as severe weather, but a thunderstorm with heavy rain and lightning would. Tornadoes, blizzards, hurricanes, floods, and droughts are other forms of severe weather that can be dangerous to humans. But the more you know about these weather events, the less scary they seem. Let's start with tornadoes. A tornado is a fast-spinning column of air that stretches all the way from a thunderstorm cloud down to the Earth's surface. With wind speeds of up to over 300 kilometers an hour, tornadoes have the power to pick up and destroy everything in their path. While not quite as windy as a tornado, blizzards are storms with blowing or falling snow, high winds of their own, and cold temperatures. Hurricanes, or typhoons, are storms with high winds and heavy rain that start over warm ocean waters and bring lots of water with them. Speaking of lots of water, let's talk flooding. Floods happen when too much rain forces streams, rivers, and lakes to overflow, sending lots and lots of water where it doesn't belong, like your backyard. A drought is sort of the opposite. Think a lot less water, or no water at all. Droughts happen when an area doesn't receive enough rainfall, drying up rivers and lakes, killing trees, and ruining crops. All of those forms of severe weather have a big impact on the biosphere and the geosphere. How so? Let's find out. I'll conjure up some different types of severe weather to see exactly how shakeups in the atmosphere can impact the biosphere and the geosphere. Severe weather can be dangerous for people, obviously, but beyond affecting humans in the biosphere, severe weather can also affect plants and animals, too. Take a drought. After very long spells without enough rain, this nice mountain pond will become smaller, and maybe even dry up entirely. That means less habitat for the animals that live in the water, like ducks and beavers. But it also means less plant life around, because plants need water too. And fewer plants mean less food for animals like deer and elk that feast on them. But what about the opposite problem? What about too much water in the form of heavy rain? Really strong thunderstorms can sometimes bring lightning and high winds that can damage trees, maybe breaking off some of their limbs, uprooting them, or even setting them on fire. This is bad news not only for the tree, but also for everything that lives in it. And finally, even the ground, as solid as it might seem, can be reshaped by severe weather. Strong, recurring floodwaters act like powerful rivers and can actually wear down rocky formations like mountains over time. And sometimes big flows of rainwater can cause a slope or hillside to collapse in an event called a mudslide. The atmosphere interacts strongly with the other spheres of the environment, particularly when it's cooking up severe weather. It can even move things in the biosphere and reshape the geosphere. So now you know how to tell if weather is severe or not. Ask yourself, does it put life or property at risk? Does it have a major impact on the biosphere and the geosphere? If the answer is yes, you're not dealing with normal weather patterns. Severe weather might be less common, but it has a much bigger impact on the world around you. Anything to add, Thunder? I guess that means we're done.
All right, so we just talked about all those seasons. Watched that video. I hope you guys really enjoyed it. It does a great job of breaking down those extreme weather patterns for you. So now that we've talked about the extreme weather, let's cover seasons. I'm sure you guys are familiar with seasons, but let's explain them here. So seasons are 4 different times during the year with different types of weather. So the seasons are spring, summer, fall, and winter. So the reason why seasons happen is because as the sun orbits around the sun, its rotation on its axis or tilt causes the seasons to change. So this is the Earth's axis. It tilts on it. As you can see, we're talking about our part of the planet. We live in the northern part of the planet. As it rotates either away from the sun or towards the sun. So in the winter, we're away from the sun. In summer, we are towards the sun. Spring, we're starting to shift from away from the sun to closer to the sun. And in summer, we go into fall, we start to tilt away from the sun, and we go into winter. So, seasons, spring, let's talk about it. So it starts around March 20th or 21st, depends on where the sun is in its rotation. So plants start to grow and some even flower during this time. I'm sure you guys have seen that. We're in spring right now. Humans begin to grow crops, and animals come out of hibernation, prepare nests, and migrate. Summer starts around June 21st. Again, it depends on the Earth's rotation around the sun. So during this time, plants grow the most this time of year. So you can see we got a beautiful flower field over here. Humans celebrate summer around the world with different festivals. So this is like a hot air balloon festival. There's music festivals, art festivals, things like that. And animals raise their young to near adulthood. So we got some owls over here. Heat waves occur during the summer. So heat waves are very hot days in the summer. I'm sure you guys are familiar with this. When it's like almost 100 degrees or more, that is a heat wave. That is unusually warm. So let's discuss fall. Fall starts around September 22nd. Plants prepare to hibernate and shed their leaves. That's why we see all the leaves falling in fall, because the trees are getting ready to sleep for the winter, go dormant. Humans harvest crops and celebrate in different ways. So, fun fact, Halloween originates from harvest festivals dating back thousands of years. So that means many cultures and different people celebrate harvest time, which Halloween is based off of. Also, animals begin to prepare for hibernation or migrations. We got some mallards here with the green heads. They're going to be flying south for the winter. And last, but maybe least, depending on how you feel about winter, we have winter. It starts around December 21st. Plants die and spread seeds or don't grow at all during this time. Humans bundle up and play in the snow or stay inside, as you can see from our two people over here. I would rather be this person in the winter, but hey, that's just me. Many animals become dormant and hibernate, like these bears. There's a lot of different mammals that hibernate during the winter. The reason why animals hibernate is to conserve energy, because food is really scarce in the winter and they could die from starvation otherwise, so they sleep. So we are going to talk about seasons a little bit more here. Let's watch this video.
Winter, spring, summer, fall. Seasons. I just love them all. Other than inspiring me to make up goofy poetry, why wouldn't you love the seasons? There's always something to look forward to. You already know that summer means long days of fun in the sun, and winter means shorter days, not to mention building snowmen and making lots of Frozen references. Okay, so clearly the sun and seasons are linked. But how? You already know that the sun is pretty important. It is the center of the solar system, after all. You also know that our planet, Earth, revolves around the sun, making its orbit once every 365 days. And remember, Earth isn't taking that lap while it's standing straight up and down. Instead, it's tilted on its axis, the invisible line around which our planet spins. Put together, the Earth's tilt on its axis and the orbit it makes around the sun, and you get the yearly pattern we call seasons. Let's see how. Since the Earth is tilted, for part of the year, one of the hemispheres, which is half of the Earth, is leaning toward the sun, and the other part of the year, it's leaning away. Let's follow the northern hemisphere once around the sun to see how this works. In June, the northern hemisphere is tilted towards the sun. This means that it's getting a lot of direct sunlight, light that's hitting it straight on. If you've ever sat directly underneath a bulb, you know that things can get pretty hot, and that's exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. In December, though, the northern hemisphere is tilted away from the sun. It's getting indirect sunlight, meaning light is hitting it at an angle. Indirect sunlight means cooler temperatures, shorter days, and, for lots of folks, hot cocoa and bundling up since it's winter. But how can the angle of the sun's light make a difference between hot and cold? Well, try this little trick with a flashlight. Get a flashlight and dim the lights in your room a little bit. If you turn the flashlight on and point it straight down onto your desk, you'll see a small, bright, concentrated circle of light. That's kind of how sunlight hits the northern hemisphere during the summer. bright and intense. Now move the flashlight down at an angle and point it at the top of your desk. See how the light isn't as bright and is less intense where it falls? That's like the sunlight we get in winter. But what about spring and autumn? During these two seasons, the Earth's orbit causes the northern hemisphere to be neither tilted toward the sun nor away from it. So temperatures during the spring and fall are more moderate, not too hot and not too cold, since the entire globe is getting about the same amount of direct sunlight at once. Now, let's take a look at how the amount of sunlight affects temperatures in the northern hemisphere over the course of a whole year. An easy way to show this yearly pattern is by using a graph. This graph shows the average high temperature in each month for 1 year in Toronto, Canada, where I live. Looking at the graph, we see that during December, January, and February, when the northern hemisphere is getting very little direct sunlight, temperatures are low. And in the months of June, July, and August, when the tilt of the Earth on its axis is causing Toronto to get direct sunlight, the temperatures are much higher. Proof positive that something is going on here, and that something is this. The season that you're experiencing right this very minute is caused in part by the amount of direct sunlight you're getting. So, seasons are caused by the Earth's tilt on its axis as it cruises around the sun in its orbit. When one hemisphere gets more direct sunlight, it's summer there. Temperatures are warmer, days are longer, and nights are shorter. And when it gets more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, and nights are longer. And now you know what causes summer, spring, autumn, and winter.
I hope you guys enjoyed that video. I think it's really cool to learn about weather and the processes behind it. We got to learn about how the Earth rotates around the sun and how that changes the weather. If you guys have any questions on the worksheets, let me know. Otherwise, I will talk to you guys later.